we're discussing the graphs of trigonometric functions. The first graph that we're going to discuss is going to be the graph of sine x. Okay. Now, if you use your calculator and find the values of sine 0, you will get 0. If you enter sine 90 in your calculator, you will get 1. If you enter sine 180, you will get a 0. If you enter sine 270, you'll get a -1. And if you find sine 360 from your calculator, you'll get 0 again. So if you join these points using a smooth curve, you get a graph like this. And this is the graph of sine x. Now, sine x, cos x, tan x, they're all repetitive function. They repeat themselves after a certain value. So if you remember, we've already talked about periodicity of sine function, and it is 360 degree or 2 pi in radians. So after every 360 degree, the graph will repeat itself. So after that, the graph would look like that again, and then again. And similarly, backwards, it looks the same. So it just keeps going on and on and on and on. After every 360 degrees, the graph of sine x will repeat itself. Okay. Now let's talk about graph of 2 sine x. This value, by the way, was -1 earlier. Okay. Now, if this becomes 2 sine x, then we've already discussed in transformations of function that the graph gets stretched by scale factor 2 and parallel to the y-axis. That means it's now going to look like this. Nothing is going to happen to the y values, but the x values would double. So you'll get a 2 here, you'll get a -2 here. So this would be the graph of -2 sine x. Okay, now let's discuss the graph of, that was the graph of 2 sine x, not -2 sine x. Now I'm going to show you the graph of -2 sine x. Okay, so we've already discussed in transformation that the graph of minus fx is a reflection on the x-axis. So it's going to reflect on the x-axis like this. But if it is -2fx, that then not only will it reflect, but it will double as well. So it will stretch parallel to the y-axis with scale factor 2. This would be 2. This will be -2. And also it will reflect on the x-axis. Okay. Moving on, let's discuss the graph of sine x plus, let's say, 2. Sine x plus 2. Okay, so this would be a transformation. This moves the graph 2 units up, right? It's a translation by 0, 2. So what will happen? The original sine x graph, which goes something like this, will go 2 unit up. So this is the central line of the original graph. It's at 0. And when it goes 2 units up, the central line would be at 2. So let me just change the scale slightly so that it can fit in the given grid. So let's say this is 1 and this is 2. So the central line would be here. Now the graph would be drawn above this central line and below the central line. And the highest value of graph would be 3 because originally sine is 1 unit above the central line and 1 unit below the central line. Now it's going to go till 3 and 1. So I'm going to make dots here again. So these values get projected on the new central line. And now I'm going to make a similar graph, but transformed graph. This graph has translated 2 units up. Okay. Next, we will be discussing the graph of, let's say, -3 sine x, -1. So, -3 sine x, -1. Okay, so now again, the graph is going to reflect. It's on the x-axis. It's going to stretch parallel to the parallel to the y-axis with scale factor 3. And also it's going to go 1 unit down, that is, it's going to translate by 0, comma, -1. So firstly, I'm going to just reflect the graph. I'm just doing minus sine x first. So then it's going to look like this. Highest value will be 1, lowest value would be -1. Now I'm going to times it with 3. So it goes like this, 3 down, sorry. So 3 down, let's say this is 3, and 3 up. So 3 and -3. Okay. Then this graph has to be moved 1 unit down. So the original central line, which was at 0 originally, this was the central line, but now it's going to be here. Goes 1 unit down. So now the graph will be drawn around this central line. So it's going to go 3 below the central line, 3 above the central line, like this. And since the central line is at -1, it goes till -4 downwards, and upwards -1 plus 3 would be 2. It goes till 2. So I could make dotted line here as a reminder that that's the maximum value, and a dotted line at -4 as a reminder that this is the smallest value. And the central line. And also I'm going to project these points here. So 90 is here, 180 is projected here, 270, 360. Okay, so now an upside down graph. So the graph is reflected on the x-axis. It got stretched by scale factor 3. Look, this is 3 units. This is 3 units. And it also came 1 unit down. So that's the graph of -3 sine x -1. Okay. You could be asked to plot the graph in radians. Then 90 would become pi by 2. You write pi by 2 here, you write pi here, you write 3 pi by 2 here, and you write 2 pi here. Rest everything is going to stay the same. Okay. Next, we're going to discuss the graph of, let me check from the worksheet, I believe sine square x. Yes, no, sine 2x and then sine half x. Okay, so let's discuss the graph of sine 2x. Okay, now what is f2x? It is a stretch parallel to the x-axis with scale factor half. Okay, so what should this look like? Okay, let me first draw the original graph of sine x. So the original graph we know looks like this. It's between 1 and -1. And if it's sine 2x, it's going to stretch parallel to the x-axis with scale factor half. That means now the graph will look like this. And it continues, of course. The graph keeps continuing in both the direction. So let me just show you the original graph again without the repetitions. So the graph got stretched parallel to the x-axis with the scale factor half. So this is what it looks like. So the graph, completes its one cycle at 180 degree, and then it repeats itself. Another way of remembering this is that since this is 2x, so the graph will complete 2 cycles at till 360 degree. So this is one cycle, and here's another cycle. So this is the graph of sine 2x. Okay. Let's also discuss the graph of sine half x. Okay. Sine half x would be a stretch parallel to the x-axis with scale factor 2. So now it's going to double. It'll go like this. And then it will go like this. So this is the graph of sine half x. Okay. Next, we're going to discuss graph of sine square x. Okay. So if the values get squared, that means we're not going to have any negative region. Instead, this region is going to become positive and it goes upwards. So the graph of sine square x actually looks like a bit like an M, like the M from McDonald's. It looks like this. This is the graph of sine square x, and its lowest value is 1, and its lowest value is 0, and its highest value is 1. That's the graph of sine square x. Now they might ask you to double it. So then the graph of 2 sine square x would look like a McDonald's M that goes till 2. They might tell you to reflect it as well and multiply it with 3. Then it's going to be an upside down McDonald's M. I don't know why I'm so obsessed with McDonald's today, probably because it's dinner time. Okay, so it's going to be an upside down M, and scale factor is 3, and it's of course reflected on the x-axis as well. Okay, moving on. Now let's talk about graph of cos x. Okay, let me clear all of this. Let me just check that I'm sharing the right screen. Yes, thank God. I'm in no mood of doing this all over again. Okay. All right, so now we're sketching the graph of cos x. Okay. Again, if you take out your calculators, you find the value of cos 0, you'll actually get 1. Okay. If you find the value of cos 90, you get 0, cos 180 minus 1, cos 270, 0 again, cos 360, 1. And if you join these with a smooth curve, you get a graph like this. This is the basic graph of y is equals to cos x between the domain 0 to 360 degree. This is one complete cycle. That's why the period of the graph of cos x, or the period of function cos x, is also 360 degree or 2 pi. And after that, the graph just repeats itself on both sides. So something like this. Okay. Now let's discuss the graph of cos 2 cos x. All right. Cos x is between 1 and minus 1. The highest value we can see is 1. The lowest value we can see is minus 1. So 2 cos x would look similar, but it goes from 2 to minus 2. That's 2 cos x. And what if I want to plot negative, let's say 3 cos x? Then it will reflect on the x-axis and it'll get stretched parallel to the y-axis with scale factor 3. So it's going to look like this. It's going to be inverted and stretched as well. Okay. What if I need the graph of y equals 2 cos x plus 1? So now it goes 1 unit up, it translates by 0, 1, and also it gets stretched parallel to the y-axis with scale factor 2. First, I'm going to show the translation. So the central line is originally this line, but now it's going to go 1 unit up. So I'm going to make a dotted line on the here. This is the new central line, and we're going to have a part of the cos graph above this line, part of the cos graph below this line, and the magnitude is going to be 2 above it and below it. So we get something like this. Let me clear this. So we get a graph between 3 and minus 1. And we're going to draw a cos graph. Let me also project the value 0, 90, 180, 270, and 360 degree here. And now I'm going to draw graph of 2 cos x in this region. So it goes something like this. This is the graph of 2 cos x plus 1. And notice this amplitude is 2. This amplitude is 2. So it got stretched by scale factor 2. Okay. Now let's discuss the graph of, I think we've already discussed minus cos x. It just reflects on the x-axis. Let's discuss cos 2x and cos half x. Okay. So let me draw cos x again so that we can compare it with cos half x, cos 2x first, and then cos half x. Okay, so cos x is same old graph between 1 and minus 1, which goes something like this. That's cos x. Now let's draw cos 2x, which is a stretch parallel to the x-axis with scale factor half. So now the graph would look something like this. It finishes its complete cycle at 180 degree and then it repeats itself. So this is what the graph of cos 2x looks like between 0 to 360 degree, and yeah, it repeats on either side. Something like this. Okay. And what about the graph of cos half x? That's also a stretch parallel to the x-axis with scale factor 2. So now the graph, which was originally going like this, is going to go like, oops, the original graph is gone. Let me draw that again. Okay. So now the graph is going to be like this. Here's the purple marker. Okay, so like this. And that is not a full cycle. It will finish a full cycle at 720 degrees. So there's only half a cycle that is completed between 0 to 360 degree, and that is actually represented by this half. And this cos 2x actually completes two full cycle. Look, this is the first cycle and this is the second cycle. It completes two full cycle between 0 to 360 degree. Okay, now let's discuss the graph of cos square x. Okay, so cos square x. Okay, let me quickly draw cos x again. This is the graph of cos x. Cos square would again get rid of these negative values and it's going to go upwards. And this graph, the earlier sine square graph was looking like a M. This would instead look like a W. Let me show you how. So it goes something like this. Let me use another ink. So it goes like this. A W. Like this. And its minimum value is 0 and maximum value is 1. And of course, if you increase its magnitude, like if it becomes 2 cos square W, then it goes like this. From 0 to 2. Something like this. Okay, that's the graph of cos square x. Now we're going to discuss the graph of uh, tan x and its transformations. Okay. Okay. So graph of tan x. Okay. If you enter tan 90 in your calculator, you will get a math error. So you draw something called an asymptote at 90. Asymptote is, for now, is a horizontal dotted line. Then if you find tan 270 in your calculator, you'll again get math error. So we're making a horizontal dotted line to represent that. Similarly, at tan minus 90, you'll get an asymptote. At tan minus 270, you'll get an asymptote. Yeah. Find tan 0 in the calculator, you'll get a 0. Find tan 180 in the calculator, you'll get a 0. And at 360, you'll get a 0. Similarly, at minus 180, minus 360. Okay. And the graph of tan x goes like this. It shoots up, never touches this asymptote. As it goes up, the distance between the asymptote and this curve keeps decreasing and decreasing and decreasing, but it never becomes equals to 0. And here the graph starts from this end and then it finally becomes 0 at 180 degree. This is one complete cycle of tan x graph, and then the cycle repeats itself. That is why the period of tan x graph is 180, because it repeats itself after every 180 degrees. Goes like this, goes like this, goes like this. One thing you need to remember is that tan 45 is actually 1. This is 45, then you'll have 1 next to it here. So tan 45 is important, remembering that tan 45 is 1. So you'll have to plot this in the graph. This is important because if they ask you to draw the graph of, 2 tan x, then you're going to write 2 with 45. And similarly, if they ask to draw the graph of 3 tan x, you're going to draw 3 next to 45. All right. Now let's discuss the graph of negative tan x. Let me just cut paste the graph from the worksheet to save time. Okay. Minus tan x is again a reflection on the line on the x-axis. So it looks like this. Let's compare the two. So see, every curve, they've only shown the right-hand side here. They've only shown this part. So what was going up earlier like this goes down. What was going down earlier goes up. So every curve gets reflected on the x-axis. Okay. That's minus tan x. Let's look at a couple of more variations. Okay. Next is negative 2 tan x, negative 2 tan x plus 1. Let me show that. Okay, first it's negative 2 tan x and then negative 2 tan x plus 1. Okay. Okay, so negative 2 tan x is again a reflection on the x-axis, but now with 45 or negative 45, you get 2 corresponding to that, as discussed earlier, not 1, but 2. And for negative 2 tan x plus 1, this graph is going to go 1 unit up. So this is the central line, but now this is going to be a central line. And then you're going to draw the rest of it about the central line. Okay. Now let's discuss the graph of tan 2x. Okay. So tan 2x would mean that it's a stretch parallel to the x-axis with scale factor half. So earlier, let me just try getting rid of all these highlights here. Okay. So, okay. So earlier, this curve was from 0 to 90. But now this curve is going to be from 0 to 45 because we have stretched the graph parallel to the x-axis with scale factor half. Okay. And then this graph and then earlier the asymptote was at 90, but now it's going to be at half of 90, that is 45. And then this lower part was earlier going from 90 to 180, but now it's going to go halfway from 45 to 90. And similarly, the other curves are repetition of the earlier curve. So every value on the x-axis gets multiplied with half, and we get a kind of a squeezed graph. Okay, and earlier the graph was completing one full cycle from 0 to 180, but now it will complete two full cycles from 0 to 180 degree. And this is how you can remember this two as well. Two means two full cycles are completed within the same one period. Okay, moving on. What else do we have in the worksheet? We have tan square x. Okay. Let me show tan square x to you now. Here's tan square x, so it's not going to have any negative values. So every negative value gets reflected upwards. So let's ignore this negative part and look at the positive part only. So this line was already positive. It stays the same. However, it becomes U-ish. Earlier it goes like this, but when you square it, it becomes a little sluggish and rising. So it becomes kind of like a U. And then this line, which was downwards earlier, now gets reflected upwards. And this side, which was also downwards earlier, gets reflected upwards. And remember, never to let these lines touch the asymptote, otherwise you lose mark. There's no asymptote over here. I don't know why I've done that. There's no asymptote here. Okay, that's all from the graphs of trigonometric functions. We're going to do the past paper questions in class.